Welcome, good afternoon, everyone. For those of you who do not know me, my name is Jake Ayre, Vice President of Keystone Agricultural Producers, and I'm a farmer and pedigreed seed grower from Minto, Manitoba. So I'd like to welcome you all back to this afternoon's session entitled Agriculture and the Environment. We have our keynote speaker, Dr. Danny Blair, as well as a Q&A afterwards with a moderated panel. So I'd like to take this opportunity to thank our sponsor of this panel, the cooperators, and then I'll lead with an introduction of Dr. Blair here. Dr. Blair's presentation will discuss the impacts of climate change and some implications for agriculture. As I said, after the presentation, I'll moderate a Q&A session with Ted Menzies, former Member of Parliament and Minister of State, and President and CEO of CropLife Canada. As well, Christine Tapley, a producer and regional agrologist with Ducks Unlimited Canada. At this point, I'd like to introduce Dr. Danny Blair, a geography professor at the University of Winnipeg and co-director of science for the Prairie Climate Center. Dr. Blair obtained his bachelor's and master's degrees from the University of Regina and a PhD from the University of Manitoba. His main research interests are climate variability and climate change in Canada's Western interior. He was a contributing author of Canada's National Assessment of Climate Change, released in 2008, and as a frequent presenter and participants in workshops about climate change in the Prairie provinces. Turn it over to you. Thank you, Dr. Blair.
Well, thank you very much for the opportunity, all of you at CAP, for the opportunity to speak to this important group. We have a lot of respect for CAP at the Prairie Climate Center, and therefore I could not turn down the request. So I'm going to share my screen here, and I have a quick review of climate change around the world and in Manitoba in particular, with implications for Manitoba. Jake, can you see my screen? Everything okay?
Yes, you're good to go here.
Great, thank you. So let's get right to it. I have a lot to say. First of all, a global update, if you don't mind. And here we go. As you probably all know, the globe is getting warmer and continues to get warmer. 2021 turned out to be about 1.1 degrees warmer than pre-industrial. And by pre-industrial, I mean the period back here, if I get my pen working. Pre-industrial is the latter part of the 1900s and early part of the 1900s. That's our reference period for this. And what we see is that indeed 2021 continued the trend of really warm temperatures. We've had some warmer years in the years preceding 2021. 2021 was tied for sixth warmest, tied with 2018, as it turns out. It's the trend, of course, that is the important thing. Individual years are going to go up and down for a lot of reasons, some of which we're going to discuss here in a few seconds. Most importantly, the wiggle in the global temperature that we see there, much of that is related to El Nino and La Nina. I think we're all familiar now with what El Nino and La Nina is. El Nino is when the Pacific, much of the Pacific is warmer than normal, and La Nina is when the Pacific is cooler than normal. We are decidedly in a La Nina situation, and we're experiencing what is typical of La Ninas, and that is relatively cool winters in Western Canada. Another way that the global temperature flickers, if you will, that it just doesn't go warmer and warmer and warmer under the influence of greenhouse gases, is volcanoes. In 1991, there was Pinatubo. In 1980, I think it was, or 1983 was El Quichon. In 1963 was Mount Agung in Southeast Asia. Volcanoes have the ability to put up a lot of material into the upper atmosphere that can block out sunlight temporarily. And as you might know, we recently had a big volcano in the South Pacific, the Tongan eruption. And as you might have heard in the news, it sent shockwaves around the world. That was recorded, I must say, at my weather station at the University of Winnipeg. That little blip there doesn't look like very much. That's perfectly timed with the shockwave that emanated from Tonga and went out towards Manitoba from the from the coming from the southwest. And then I think there was another little blip here timed with the shock wave coming from the other direction. But fortunately, or perhaps more of interest than fortunate, is that this particular volcano, as explosive as it was, it's very unlikely to cool the climate for a couple of years like Mount Pinatubo and other large eruptions did. There just wasn't enough sulfur dioxide put into the atmosphere. It didn't erupt as long as Mount Pinatubo. And therefore, climatologists are pretty convinced that the Tongan eruption is not going to cause a little bit of cooling for a couple of years, which would have been a good thing from my point of view, because we're going to get warmer as we go forward in time. And here's the La Nina signal. This is a map of sea surface temperature anomalies, how colder or warmer than normal the sea surface temperatures are. And that's a classic signal. These cold temperatures in the Pacific here are classic signals for a La Nina. And that's going to stick around until the spring. And then maybe we'll transition next year into a El Nino situation, which will make the world a little bit warmer than normal. But whether El Nino is present or La Nina is present, or whether volcanic eruptions are occurring, we're going to get warmer because of course, because of carbon dioxide. We're adding a very large amount of carbon dioxide into the atmosphere and continue to do so, and will continue to do so for a long time, even despite our important efforts these days. In 2020, the average amount of carbon dioxide in the atmosphere was 416 parts per million. Notice that the pandemic lockdown does not show up in this graph of carbon dioxide concentrations. Yes, the world's industry shut down for a little while there, and carbon dioxide emissions were reduced, but it really didn't have any impact upon the global carbon dioxide concentration. So that's a bit unfortunate, but that's the way it is. And so carbon dioxide has increased enormously since 1958, when we first started to measure it very, very accurately. And it's going to continue. And the question, as you might know, is how high is it going to go and how rapidly? And that's pretty much what is going to determine our climate of the future, including our ag climate. The IPCC, the Intergovernmental Panel on Climate Change, last summer released its latest volume of information about what we know and what we don't know about climate change. And it's clear, it's so clear that the rate of warming that we're seeing now in the world is unprecedented, and at least the last 2,000 years. And paleoclimate evidence from ice cores and other kinds of evidence that we dig out of the ground in the bottom of the ocean and tree rings and so forth, paleoclimate evidence indicates the world has not been this warm for at least 100,000 years. That is, you have to go back 100,000 years to see the world as warm as it is right now. And if we continue to go beyond 1.1, if we go past 1.5 and 2 and go all the way up to 2.5, let's sure hope we don't go that way, the world will be warmer than it's been in 3 million years. The rate of temperature change, the level of temperature change that we're experiencing in the globe is just remarkable and unfortunate from my point of view. And indeed, if we look back at the ice ages of the last 800,000 years, here is where the world was warmest 100,000 years ago. And this graph is showing the amount of carbon dioxide in the atmosphere. And so over the last million years or so, carbon dioxide never went up about 280 parts per million. We're way the heck up here. And we just have to conclude, and indeed science does conclude, that we're going to get warmer. We're going to see some really significant changes again as we go beyond 416 parts per million to whatever it is going to be in the coming decades. And the climate models tell us that the temperatures that we're going to see across the world are really largely dependent upon the amount of carbon dioxide that we put in the atmosphere. This is a graph of temperature. This is a graph of temperature relative to what it was in 1850 to 1900. And this 8.5 scenario here shows that if we, by the end of this century, 2100, we may be almost 5 degrees warmer than it was recently. And if we follow a lower carbon solution, and there's some indications that the world is taking this seriously and attempting and going to reduce its carbon emissions by some amount. If we follow the 4.5, and I use these because these are going to show up in a little while. If we follow the lower 4.5 scenario, the world would maybe warm up only 2.5 degrees or something like that, which is much better than 5 degrees, because that amount of temperature change in that amount of time will produce remarkable changes to our world. There will be some benefit, but there is an enormous amount of risk as well. And indeed, the amount of temperature change, if we just talk about temperature change for the moment, the amount of temperature change that we are going to experience in North America is greater as the world gets warmer, not surprisingly. If the world warms up by 1.5 degrees, which it will, it's going to go past 1.5 degrees. We see quite a substantial amount of warming in North America, including in Manitoba. If the world warms up by 2, it's more warming. If the world warms up by 4, let's hope that doesn't happen, we see a lot of warming in Manitoba and beyond what we've already experienced. And again, there are some benefits, but there's a lot of risk associated with that. From a precipitation point of view, the warmer the world gets, the more the precipitation patterns get energized, if you will, or perturbed. Green means wetter. And as you see across North America, including Manitoba, we're going to get wetter as the world gets warmer. But there's as you as ag people know, there's a lot of uncertainty with precipitation forecasts and precipitation projections from a climate point of view. But the more the world warms up, the more the precipitation patterns are exacerbated. In general, the wetter places get wetter and the drier places get drier in a way. So what about a Canadian update before we get to Manitoba? Well, as you might know, if the world warms up by 2 degrees, Canada warms up by about 4 degrees. The rate of warming across Canada is about double the global rate because of our particular location in the mid-latitudes and higher latitudes. Canada is warming up at about double the global rate, and the Arctic is warming up at about triple the global rate. So when you hear in the news that the world will maybe reach 1.5 degrees, that means 3 degrees across Manitoba or Canada as a whole, and 4.5 degrees in the Arctic. Again, it's our geography, our location in the climate system and how it operates in the mid and higher latitudes exacerbates the warming in our part of the world, unfortunately. Now, the problem, of course, with changing the average temperatures, or one of the problems in changing the average temperatures, is that the extremes, the probability of extremes changes. Now, obviously, as we shift towards a warmer climate, if the averages change, we see fewer really cold days. Now, I say this as, this morning it was -35 at the airport in Winnipeg here. We're still going to have cold days. We're just not going to get as many of them. But we are going to get more of the hot days because the bell curve, because the normal curve shifts to the right. The probability of really high temperatures goes up. The probability of really cold temperatures goes down. As a brief aside, we are definitely across Canada seeing less of the cold weather. Here's a graph that shows that, for example, Alert in Nunavut has experienced since 1950 fewer and fewer -30-degree days. This is a graph of the number of -30-degree days every winter. And Alert, way the heck up at the top of Canada, and many, almost all northern stations in the Arctic are seeing very many fewer -30-degree days. And if we follow the RCP high carbon scenario, RCP 8.5, at the end of this century, Alert may only have a couple weeks of -30, whereas in the 1950s, they had 140 days or so. Climate change is happening, and it's very evident in the Arctic of Canada, but also very evident in our part of the world as well. Now, again, before I talk about Manitoba specifically, of course, one of the big news items this year was the extreme temperatures in British Columbia, the remarkable extreme temperatures in British Columbia and Washington and Oregon, as a clear example or a very good analog about what we should expect to experience with global warming. There was a very, very unusual atmospheric pattern, a very, very strong ridge, a heat dome, they called it this year, in Western Canada at the end of June and the beginning of July. And that heat just built up and built up and built up. and produced, of course, some remarkable temperatures in British Columbia and elsewhere. Here's a graph of Vancouver's maximum daily temperatures. All the black dots are all the daily temperatures that it experienced, all the daily maximum temperatures from 1898 to the end of 2021. The red dots are what they experienced in 2021. And there you can see at the end of June, British Columbia, Vancouver, that is, had temperatures over 40 degrees in Vancouver. And Victoria had 4 days in a row of record temperatures, maxing out just below plus 40 degrees. Jasper went over 40 degrees. Jasper, British Alberta went over 40 degrees. But of course, what really got attention, Canadians' attention and the world's attention, was that Lytton, BC, which of course is known for a really warm summer climate, it had 4 days in a row of progressively higher and higher maximum temperatures ever recorded in Lytton. And they maxed out at 49.6 degrees, the highest temperature ever recorded in Canada. The previous was 45 degrees in Yellowgrass, Saskatchewan, and Mydale, Saskatchewan, and back in 1937. Yellowgrass is where my mom actually grew up. So my mom was there for the previous, when she was a young girl, in Yellowgrass for the previous record high temperature ever recorded in Canada. And then as you could see, the temperatures this year in Lytton just were literally off the chart. A remarkable extreme meteorological event, indicative of the probability of really high temperatures going up as the average temperatures go up. This event shocked climatologists such as myself. You know, we were just like, what? This just doesn't make sense. And when we evaluate, or when statistical climatologists evaluated this, they showed quite definitively that this could not have happened. These kinds of temperatures could not have happened without global warming or climate change, whatever you want to call it. They were so extreme that they lie far outside the range of historical observed temperatures. We saw that off the chart. And it is probably, in the most realistic statistical analysis of the event, it's estimated to be an event that should only occur once every 1,000 years. And as the average temperatures of British Columbia and the world go up, it will become more and more probable. And that's unfortunate, because these kinds of events do damage. They kill people, in particular heat waves. 595 people died from the heat wave in British Columbia this year, 99 of them in Vancouver. And why do people in Vancouver and British Columbia die from heat waves? Because they don't have air conditioning. In Manitoba, we have the highest rate of air conditioning adoption. 90% of the households in Winnipeg have air conditioning. In 2019, only 33% of the homes in BC had air conditioning, and 28% in Vancouver, and only 17% in Victoria. They have more now because they've been woken up, if you will. But it was this is a kind of climate event or a weather event that they're just not ready for. This is indicative of what we need to do. We need to get ready for these big changes in the future. And in ag, we need to get ready for them to take advantage of the benefits and to minimize the risks associated with these amazing changes in the climate system. And as you might know, there was this enormous precipitation event in British Columbia as well. And that is indicative of climate change as well, because a warmer atmosphere can hold more water vapor. All of you know that. The air in the summertime can hold a lot more water vapor, and therefore the precipitation potential is much greater. And we saw that in this atmospheric river event in British Columbia, in the same year that we had this incredible heat event, we had this incredible precipitation event where moisture poured in from the Pacific Ocean state and just kept doing so for a few days. And so a place like Hope, BC had 277.5 millimeters over 2 days. They had a very, very large amount of precipitation in very short order, which is indicative of climate change again, because climate change says that we should experience more extreme precipitation events, and we are across the world. And now let's turn to Manitoba. Of course, the big weather event this year for Manitoba was the drought. And of course, at the end of July, the drought was very extensive across Western Canada. The Interlake and parts of southern Manitoba were in the depths of a really bad drought of the sort that we hadn't seen in a long time. Much of Western North America remains in drought. In the United States, of course, they're having this terrible drought in the Western United States that just won't go away. But now it was our turn to have a really good drought of the sort that we haven't seen in a long period of time. And of course, speaking to you, of course, this had enormous impact upon agriculture. I'll just skip that. And indeed, if we look at the precipitation, now I'm going to just slow down for just a second and explain these graphs. These are graphs that show, in this particular case, total winter precipitation in Winnipeg. Now, I know Winnipeg is just one station across Manitoba, but it's the one I've chosen here. We'll have some other ones in a second. But this is the winter precipitation from observed weather stations that observed at weather stations from 1873 to 2021. These are update. I have data up to the end of 2021. And so you can see, as you well know, precipitation is enormously variable in this crazy climate of ours. But we did have, over the last couple of winters, we had some really low amounts of precipitation. Here we are in the winter of 2021, really low amounts of precipitation. And of course, and notice that on these graphs, I have the projections, the climate projections under that high carbon scenario and under that low carbon scenario. And as you can see, winter precipitation is expected to slightly increase in the coming decades, some wetter winters. Not horribly wetter, but wetter. And if we go to the spring, of course, you all know that spring last year was very dry. Springs are expected to get slightly wetter as well. Again, enormous amounts of variability in our crazy climate from year to year. And in summer, again, lots of variability, but now notice that the projections indicate slight decline, very slight decline in precipitation in Winnipeg and across southern Manitoba, the ag region of Manitoba in the coming decades. Not a horrible drop in precipitation, but put that in the context of having also very high amounts of high temperatures, and we have the great potential for a large amount of evapotranspiration, a drying of the soil, of the sort that we definitely had in this drought this year. July across many parts of Manitoba was the driest July on record. It was in Winnipeg. And then here's a map that shows that indeed July precipitation in the future, in this case, we're looking at the far future, 2051 to 2080, under the high carbon scenario, precipitation is expected to be lower than it is now across much of southern Canada, including the prairies here. And again, not a huge drop in precipitation, maybe 5 to 10%, but with the higher temperatures, that produces a greater probability of droughts, unfortunately. And fall precipitation was lower as well. I'm going to move on. So here's the total annual precipitation observed in Winnipeg from 1874 to 2021. Again, you can see enormous amounts of variability in this climate of ours, a rather low amount of precipitation in Winnipeg and many parts of southern Manitoba and the prairies in 2021. And the projections are for total annual precipitation to go up slightly because of the slightly wetter winters, springs, and falls, but countered a little bit by the slightly drier summers, according to the projections. But where we've really seen changes is with precipitation. Here's the average winter mean temperature in Winnipeg. And as you can see, I've overlaid on top of it as well, the high carbon scenario projection and the low carbon scenario projection, indicating that temperatures in the winter are, whether you're under the high carbon scenario or under the low carbon scenario, no matter which path we follow, it's going to be warmer in the future winters. And there, of course, there are some benefits to that, to agriculture and society as a whole, in terms of cost of heating and stress on animals and other things. But winter temperatures have definitely risen in Winnipeg, and they've also risen in the spring. Again, enormous variability. There's last year's spring temperatures in Winnipeg, those dots right there. But we've had in recent years, well, not so recent, but we've had some really cold springs, and we may have that again this year. But on average, the temperatures are going up. And if I go to summer, we see temperatures in Winnipeg and across Manitoba going up and projected to go up. And remember that if you look at the future scenarios, you have to overlay the variability on top of that. And so in the coming decades, we could see some really warm summer temperatures of the sort that we've had much more often than we have had in the past. I'll just skip that. And the fall temperatures are going up as well. But of course, we've had some really cold falls recently. But on average, the temperatures in the falls have gone up, especially in September. And where they're going, well, it depends upon which carbon scenario the world follows, whether we follow the high carbon scenario or the low carbon scenario. Let's hope it's the low carbon scenario. Here's the average annual temperature in Winnipeg. And as you can see, there's a decided trend. And the trend beyond now is under the high carbon scenario, low carbon scenario. As a climatologist, I can't see how we're not going to go much higher. And again, you have to overlay the variability on top of those smooth lines there to show that we could have some really warm temperatures in the future, annually, seasonally, and monthly. It's not just in Winnipeg. Here's Dauphin. I'm going to flip through these very quickly. Here's Dauphin. So, again, why I'm showing some other stations is, well, farming happens outside of Winnipeg. But it's not just Winnipeg. It's not just the urban heat island or some effect like that. It's happening out in rural Manitoba as well. There's Dauphin. There's Nipawa. There's Portage la Prairie. Temperatures going up. These are the annual temperatures, you remember. There's the Paw, temperatures going up. And finally, here's Swan River. Swan River has data going back to the 1950s, and there's a decided trend in the annual temperatures, as there is in many of the months and seasons associated with Swan River. All of this information is available, or much of this information is available on the Climate Atlas of Canada, produced by the Prairie Climate Centre. We are proud to be a part of the portal system, the climate data portal system associated with Environment Canada. ClimateData.ca is another site to get data about what the climate might be like in the coming decades, according to the high carbon scenario, low carbon scenario. There's a power users version of that at Pavix, that Pavix site there. But the go-to site, I would suggest, is the Climate Atlas of Canada, where we make data available in a friendly way, and we have nice pretty graphs and stories and videos to tell about climate change in Canada, including Manitoba, of course. So what I've been saying for a very long time, and what you've been hearing for a very long time, is that because of these changes driven by the carbon dioxide, the growing seasons are getting longer. There's definitely more heat available in the ag climate of the present compared to the past, and much more is coming in the future. Fewer episodes of really cold temperatures. We're still going to have cold temperatures, but a lot fewer of those events. More precipitation overall is what we expect. Perhaps less precipitation in July and August, the latter part of the summer. Precipitation forecasts and projections, climate projections, are more uncertain than temperature projections. So we'll see how that plays out. But the expectation across most models and most climatological organizations is that precipitation is going to decline in the summer in the future. When it does come, it will come more intensely, which is not a good thing in terms of being usable to moisten the soil and water the crops. If it runs off because it's so intense, it's not very good. And then a greater threat of drought because of the higher temperatures and perhaps because of the lower precipitation in the summertime. And even more variability in our, as I often say, in our crazy climate than we already have. In an energized climate system, we should expect more variability, even more than we already have. So there are definitely benefits to agriculture: the longer growing season, the greater amounts of heat, the opportunity to grow many different kinds of crops. But there are threats associated with the increased drought, the increased precipitation intensity, the increased prevalence and frequency and length of droughts in the long run, And therefore, as you all know, and as you all are all doing, we need to get ready for it. We need to adapt. We need to manage our water more efficiently, perhaps, than we already do. We need to do research and innovation to try to take advantage of those opportunities and to minimize those risks. And to do that, you need data and advice. And the Prairie Climate Center and Climate West are there to help you do this should you need it. The Canada Water Agency is being proposed as an agency to oversee more efficient water management on the prairies, and we'll see where that goes. So in the upcoming discussion here, I'm really interested to hear how ag people such as yourself think about the opportunities, think about the risks, think some comments about what you're actually seeing on the ground. This is a great opportunity for me to learn from you. So with that, I thank you. And I'm going to stop sharing my screen there and turn it back over to Jake.
Thank you, Dr. Blair. Interesting topic. I know I wrote down about 2 pages of notes, so I took something out of it myself. Maybe I don't think I'm the only farmer who likes hearing about the weather. So thank you very much for that. Now, I'd like to take the opportunity to introduce our panelists. So we have Christine Tapley and Ted Menzies. So I'll start off with Christine. Christine and her husband run a cow-calf operation in Langeruth, Manitoba. She graduated from the University of Manitoba with a Bachelor of Science in Agriculture, with a major in agroecology and a Master's of Science in Animal Science. Christine was awarded a mentorship with the Canadian Cattlemen's Association Cattlemen Young Leaders Program, where she focused on beef sustainability. Christine's farm was awarded the Environmental Stewardship Award by Manitoba beef producers for grassland restoration work in 2015. Christine now works for Ducks Unlimited Canada as a National Agricultural Sustainability Lead. Through her work for Ducks Unlimited, she has held a seat on council at the Canadian Roundtable for Sustainable Beef, Manitoba Protein Consortium, and Manitoba Beef and Forage Initiatives. And as well, I know I've had the pleasure of working with Christine at CAP on our Young Farmer Committee. Welcome, Christine. And Ted Menzies. Ted Menzies is a longtime farmer and advocate for agriculture. Ted was president of the Western Canadian Wheat Growers Association, founding vice president of the Grain Growers of Canada, president of the Canadian Agri-Food Trade Alliance, and director on many other boards and committees. Ted was first elected as the Member of Parliament in 2004 for McLeod, a riding in Alberta, and has served as parliamentary secretary before being appointed Minister of State for Finance in 2011. After leaving government in November 2013, Ted was selected as president and CEO of CropLife Canada, retiring in January of 2017. Ted continues to be active in a number of organizations, including the Canadian Ag Hall of Fame Association, Alberta's Ag for Life, and chairs the Responsible Grain Code of Practice Development Committee for the Canadian Roundtable for Sustainable Crops and more. Again, I'd like to thank our sponsor for this panel, the cooperators, and we will get our Q&A going. Christine and Ted, can you hear me all right? Thumbs up.
Clear.
Yeah, so I just wanted to take the opportunity here to start with something that the Dr. Blair had said he was curious to hear. So we'll start right off with that. So first question I was wondering if you could both elaborate on is producers are known for their ability to adapt and to change, whether it's their operations or structure, what it may be. So I was curious, what are you seeing and hearing producers are doing across the prairies in regards to a changing climate? And what are you seeing or hearing that producers may implement to combat a changing climate? So I don't know if, Ted, did you want to answer that one first?
We should have ladies first, shouldn't we?
Sure. Christine, do you want to start us off? Put her in the hot seat there, Ted.
Yeah, I think this is kind of on the tip of everybody's tongue is how do we brace for those crazy charts and extremes that Dr. Blair just showed us. I got to sit in on the discussion the other day, which I'm sure many of you did, on the new Manitoba water strategy. And a lot of that discussion, of course, was on how do we hold water so that we can use it when we need it. And I think that we saw that very clearly in those charts that he was showing us today. So thinking about how do we keep that water on the landscape in a way that we can use it effectively throughout the season is certainly really important. And then I think also that that preparation for how we're going to change maybe how we feed. So of course I'm a beef cattle producer and was very aware of of that situation this year, and so and it wasn't just this year. I think that we were all hit by that buildup because we've been dry for a few years now in a row, and so our stocks were maybe dwindling even before this hit. And so I think finding solutions that will help us kind of ride that wave will be important. But I'll hand it over there if that's
All right, thanks, Christine, and thank you, Jake, for allowing us the time to respond. Some pretty much a wake-up call in what the good doctor has shared with us today. I think we as farmers have seen the changes. Let me just give you one example. I live in southern Alberta, and I look out my kitchen window and I can see the snow-capped Rocky Mountains. 10 kilometers from my house, we now have a 24-hour a day, 7-day a week soybean processing plant. So are farmers adapting? Yes, they are. They're realizing that we're now, certainly the genetics have changed, there's no doubt about that, shorter season varieties, but waking up to the fact that we're going to be growing different crops. And I've used this in many speeches, and people will give you a strange look when you say this, is we are going to be beneficiaries of climate change in Canada. And many countries are not. And so we need to recognize that we have the responsibility, not just to adapt, but the responsibility to provide food for those regions and those countries that will not be able to adapt, that will not be able. Madagascar, prime example in the last year, they couldn't grow enough food to feed themselves. They've never been great, but this is just proves to us the responsibility we must take, whether it's changing to where possible, cover cropping, moving to zero till. And I moved to zero till back in the late 80s, and farmers have adopted these changes because even then we realized that what little moisture I got in my part of the world, I need to conserve that. One experience that has taught me a lot about recognizing what all farmers across Canada have to deal with, it was this roundtable for sustainable crops, putting together a code of practice for grains and oilseeds. My issue in my land is how to keep enough water, how to get enough water. And yet talking to colleagues in Quebec and Ontario and Manitoba, how to deal with excess water at certain times of the year. So that there's lots we can share and learn to help each other adapt.
Thank you for that, Ted and Christine. I wanted to elaborate on something that both of you kind of hinted at, is that, you know, this isn't, and all the data shows that it's not just a one year cycle we're in. We're in a changing climate. So I'm curious, both of your thoughts on how can a producer prepare for, you know, a potential another year of a drought. I know, Christine, where you are, it's been dry for 3-4 years. My part of the world, it's only been about 2 years. So how can producers prepare for another year or 2 or 3 of continued drought conditions?
So I think I can jump in. Something that I think plays on the adaptability and that preparation question that you have, and the last is, I think, especially in Manitoba, more and more byproducts are available, and we're starting to find ways to use them and feed them. And it seems like lately there's been this big conversation around regenerative agriculture, and everybody's thinking about what that means. And one of those principles is crop and livestock integration. And I want to encourage people to not think about crop and livestock integration on an individual field or even on your own farm. I don't mean hooves on stubble, although that's really great. But it could mean feeding byproducts and finding other feed sources and thinking about ways to be really creative and adaptable, and planning that adaptability or how to use those byproducts, because probably the same byproducts won't be available every year. But if you can be creative and use them, and of course, a lot of that is already happening. I mean, we have beef producers that feed potato peel regularly. There's lots, of course, of new partnerships happening with roquettes and pea byproducts. There's folks that I know that are feeding vegetables and fruit that come out of grocery stores that hadn't got sold and things like that. So I think the rumen is a remarkable thing in that it can use all kinds of junk and turn it into a great product. So I think that that's going to be the way of our kind of beef industry, is to lean on that because of the unpredictability of growing our own food. And then I would also say, hopefully, we will find ways to more seamlessly transition those failed or poor crops because of those extreme events and the growing conditions that are so unreliable. We need to find easier ways to transition those into feed rather than just bottom line them being an insurance claim, I think.
So just to elaborate a bit on that, communication is one thing I would echo with that. And you're talking about alternative use for destroyed crops or that sort of thing. I know that's something in my part of the world in the Southwest where we saw that before, where we had producers working with each other and communicating that say a grain producer had a crop that was of no value or use to them, but reality was down the road they worked with that producer and communicated that, hey, I might have a feed source for you. Would you be willing to work together? So I just wanted to touch on that too. But Ted, I was curious to hear your thoughts.
Well, I think that we have a huge opportunity in plant genetics, finding ways to take drought-tolerant crops, drought-tolerant plants, and through our new technologies, be able to transpose that, whether it's through CRISPR technology or whatever it may be, improve the drought tolerance of the crops that we're growing. We can't leave water management out of this. It's a massive, we used to waste water back in our old, as I refer to it, as recreational tillage days in my part of the world. Well, you had to work the land a tremendous amount before you ever put a crop in the ground. We're down to zero till now, less passes across the field. That saves moisture, but how do we do that in winter? Stripper headers, some of the simple technology where you actually gain advantage of some of the snow, whether it's less or more, but the snow that we do get, save that for spring and reduce tillage. I've spoken with potato farmers in Prince Edward Island that are now have come up with acceptable methods of zero till for potatoes. And that has to be a challenge. I know it has to be a challenge. I've never planted them, but I know that has to be a challenge. So there's possibilities for this. The new technologies in seed development, but also in equipment that is less intrusive and helps us save moisture and be able to grow different crops.
So I just wanted to be cognizant of everyone's time. Do we have time for 2 more questions? I know we're running a bit over schedule, but seeing lots of interactions and people are enjoying the chat. So are we good for 2 more questions, Christine and Ted?
Absolutely.
Time permits. So, crystal ball question here. I'm going to put you both on the spot again. And Ted, you've touched a bit, and Christine, again, you've shared, but, looking into, say, 2030, 2040. So we're talking 20, 30 years down the road. What do you see the biggest differences between agriculture in Manitoba today and the prairies today versus, the agriculture of the future?
Let you go first once, Ted.
Okay. use of innovations, simple things where we're not using excess fertilizer, so we don't have the fertilizer waste, the runoff from fertilizer, the section management in our seeding and spraying equipment. It's simple things like that that will all add up. And if you can improve that even 1 or 2% in every operation on your farm, that certainly helps with the environment. You know, there's a lot of opportunities for Canada is leading in agricultural technology. I remember going to northern Kazakhstan and seeing air seeders, Borgo air seeders working away in northern Kazakhstan. It's because they love the technology that was developed on the prairies. And those technologies were built out of necessity, designed out of necessity. And so we are leaders. Part of what we need to do, I think, is share with our consumers. I'm going back to this developing a code of practice. Share with the consumers what we are doing, but as far as sustainable practices, because we are doing them, we have done them, and we continue to do them. But people don't understand that we're doing this. That we live on our factory floor. We live in the middle of our farms. We don't abuse our land. We take good care of it. But the other ones that we need to share this with are the governments. So they actually acknowledge the fact that we have reduced our carbon footprints. You know, going back to the presentation just previous to this, like we've made some improvements, and sorry, we're getting a bum rap for what we've done, whether it's in the livestock sector or in the grains and oilseeds sector. We're getting a bum rap. We've sequestered more carbon than most people realize. And if the government is going to be there to support agriculture, they need to recognize that what we've done on our own initiative, we can do more. And don't tax the daylights out of us on carbon taxes, because that's killing some of our farmers. Had to get that little shot in there.
Yeah, I agree, especially I think on this notion of technology. You know, so Agriculture and Agri-Food Canada released a report, I think it was in 2020, and explained that 28% of cultivated prairie Canada is economically or environmentally unsustainable, and that's a wild number to read. But I think that we only have so much land, and we know that those demands are increasing. And so we need to use all of the science and all the technology that we have to continue to produce and yield more. But I think that those nature-based solutions and those EGS that come out of that, that's where I think we can really shine. And I think that there are solutions, and it doesn't mean delivering EGNS or environmental goods doesn't mean not using technology. And that is one of my biggest pet peeves. Yes, of course we need technology, and of course we need all of the science that we possibly can get to deliver both of those things, because we know yield needs to go up. But it's also really important to produce some of those other environmental goods, maybe on that land that's not economically sustainable, right? So stop dumping money into acres that aren't making you money, and let's produce the other things that maybe some different parties want out of those acres. I think there's win-wins there, and they can go together. I think, in my opinion. But I know that you wanted to get one more question in, so
So the last one is actually going to kind of wrap everything up into a nice little bow as we've been chatting here. But I mean, it's going to be a thinking question, Christine. So I apologize. No softballs down the middle for me today. So just if you could both tie everything together, wrap it in a little bow. And the thing we're hearing and we're seeing it, and you know, Christine, you talked about it. Ted, you talked about it. How farmers are you know, getting pressured on all sides now. It's coming from the consumer who wants, you know, to know that their food is sustainable. It's coming from government in regards to environmental policies and trade now too. So I'm curious, how can farmers, and Ted, you talked about this, driving the conversation, how can producers drive this conversation around sustainability, and Christine about the environmental goods and services and the plans and the best management practices that we're using. How can they drive this conversation, and what is the difference when the conversation is farmer-led versus placed upon them? And I know both of you have been involved. You talked about the crops, the code of practice, Ted, and Christine, you talked about being involved with the cattlemen's, and I know there's been the sustainable beef and programs like that there. So just wondering if, I know it's not a short subject, but if you could both just kind of wrap it all up and touch on that, if that helps.
It's pretty scary leaving an open mic to an old politician when we like to say in 10 words what could be said in 1 word. Yeah, absolutely. We need to recognize that we have a responsibility as farmers, as producers. And what frustrates me is we have so many different organizations, commissions representing farmers. But this is one issue that is common to all of us, is getting the message out that we are sustainable, that what the food that we're growing can not only feed Canadians, it can feed the rest of the world. It can feed those, as I say, those countries that are not beneficiaries of the changing climate. And we need to be passionate about what we say and be able to talk about it with confidence that we have been carrying on sustainable practices. We've been getting better and better every year. This half section that I live on, the first place that I bought, had 60 acres of pure white alkali on it when I first bought it. And through improved technologies, it grows wall-to-wall crops now. There was one of your chat commentators mentioned, what about winter crops? There's great ideas in winter crops. We used to grow a lot more winter wheat out here than we do now. But article just this week about the increased winter canola being grown in Ontario. So there's lots of things we can do to adapt to the climate, but there's a lot we can do to share with our consumers, whether they be here in Toronto or whether they be in Bangladesh, about how we are sustainable and we're proud to be growing food for the world, some of the safest food in the world.
Yeah, so I want to go back to your point about, or your question about the farmers leading that discussion, and I think that we at the Roundtable for Sustainable Beef and a lot of different organizations know that people trust farmers, right? We know that the data shows that people believe what a farmer says and they trust them, and so that's important for us as a farming community to take that leadership and show how we're going to take action. But I think a lesson learned again at the Canadian Roundtable for Sustainable Beef really was that time and time again, we've heard the strength of this ERSP is having voices from across the value chain there and represented in building that product. So it can't be just one end of the value chain to have that discussion, and it's hard. And that was a very slow discussion on the beef side of trying to get through many of those, what should those indicators be? But once we got there, now we have this great product that everybody can stand behind. And I think that has really been a shining, we're recognized globally for what we have built here in Canada. And then the other point I want to make is, I think when we think about those natural based solutions and how agriculture can be a part of that, I think that those codes and the roundtable and the framework, it's not necessarily changing what you're doing, but as Ted's saying, recognizing it, right? And so having this framework that can be that third party to say that, to verify that, yeah, you are sustainable. Sure, it's going to help you on a path of continuous improvement and hopefully give you resources to continue to improve wherever you're at in that spectrum. But I think that if a BMP is good, like zero till for Ted was a good move for him in that direction, and he took it because it was a good BMP for his farm. But what's more important now, I think, is going to be those frameworks that can show that Ted did this good practice, and really measuring that on that global scale, I think is important. Yeah.
Well, I think you both, like I said, you wrapped it up very nicely in a bow and kind of summed up everything we were talking about. And I hope our producers enjoyed this session, and that Dr. Danny Blair as well heard some different thoughts. But yeah, thank you, Ted, and thank you, Christine, for this engaging session. And I hope everyone enjoyed it. With that, again, I'd like to thank our sponsor, the Cooperators, and I believe turn it back to our president, Bill Campbell, for closing remarks.
Hello. Well, thank you very much, Jake, for hosting moderating that very interesting panel and discussion. A lot of information to absorb, a lot of thinking to do over these days before we get back out on the land. But we've certainly encountered a very interesting year in 2021, and it certainly brings it into perspective. So I guess with that, I would move that we recess till 9 o'clock tomorrow, and hopefully everyone has a good rest of their day, and we will see you tomorrow.